Okay, so basically we look at how much force is on certain charged particles, so positives, negatives, and in magnetic fields as well. So knowledge that charged particles experience a force in an electric field, which is kind of what you've done in second year. Electric fields exist around charged particles. Again, you've done some of that before. Sketch electric field patterns. You've done some of that before. Determination of the direction of movement of charged particles in the electric field. Again, you've done some of that before. Definition of voltage in terms of work done and charge. That's sort of the newer stuff. Use of appropriate relationships to solve problems, including charge, mass, speed, and energy of a charged particle in an electric field, and the potential difference through which it moves. So those two equations you have come across before, but maybe not in the same kind of scenarios. And knowledge that a moving charge produces a magnetic field. Again, you have done that in the past. Determination of the force on a charged particle moving in a magnetic field for negative and positive charges. So the direction of the force, and knowledge of the basic operation of particle accelerators in terms of acceleration by electric fields, deflection by magnetic fields, and high energy collisions of charged particles to produce other particles. Right, so we're going to start off by the basics. We're recovering the stuff that we have done in second year. So, electric phenomena result from a fundamental property of matter, electric charge. So symbol for electric charge, you know already, is Q, and the SI unit of measurement is the coulomb, capital C. And there are two types of charge, positive and negative. Like charges repel, unlike charges attract. None of that is new to you, okay? And just a reminder, hopefully you all know this already, but the setup of an atom is the protons, the positive charges in the nucleus with the neutrons, and the electrons around the outside are negative. The protons and electrons have one unit charge but of opposite signs. Basically, they're the same charge but the opposite. So if you ever have to look up the charge of a proton, if it's not there, just look up the charge of an electron, and it's the opposite charge. The size of the charge on a single electron or proton is 1.6 times 10 to the minus 19 coulombs. Atoms are generally neutral because the same amount of electrons and protons are in neutral atoms. So, if the charge on a single electron or proton is 1.6 times 10 to the minus 19 coulombs, then to find how many electrons or protons are in 1 coulomb, we do 1 coulomb divided by 1.6 times 10 to the minus 19. And that comes to 6.25 times 10 to the 18 electrons. Static electricity, which you may have noticed, you have some equipment around that you're going to use in a second, occurs when there's an imbalance of electric charges within or on the surface of a material. Only electrons are transferred, protons are stuck in that nucleus, they can't really move very far, so it's the electrons that do the moving, and they're moved from one object to another. So an object with a surplus of electrons, so it means it's got more electrons than it has protons, is negative. And electrons can be transferred from a cloth to a polythene rod by rubbing. So you see there, what happens is the electrons move from the cloth onto the polythene to make it negative. So arrow and electrons. The shorthand for electrons is E with a little minus next to it. So polythene always becomes negative. Perspex becomes positive. So an object with a deficit of electrons, so that means it hasn't got as many electrons, is positive. So electrons can be transferred from a perspex rod to a cloth by rubbing. So the electrons in this case go away from the perspex and towards the rod, so towards the cloth, sorry. The cloth ends up negative. Okay. Right, so you will notice what I have put on your desk is a worksheet. This is taken straight out of the second year booklet. So I'm going to give you 5-10 minutes to have a go at the experiments. Everything you need should be on your desk, or you might need the tap. Remember, when you're doing the water experiment, it has to be a very thin stream, otherwise it doesn't work. Okay, You should have enough for one polythene and one perspex rod each, or acetate.